Improving the design of VR training applications is commonly done by reviewing playtests or playtesting videos, which is labor-intensive. To find design flaws more efficiently, we present Depth, an algorithm and visualization tool that aggregates player position data and highlights areas where users who took longer to complete the training spent more time. In doing so, the system highlights potential problem areas in the training environment in a scalable and efficient manner. We record the position of the player's head and hands as they move through space, along with the time taken to complete each step. For each step of the training and each tracked object, all position data is aggregated into voxels. Each data point is associated with the amount of time that the player took to complete that step. The average completion time for all data points within a voxel is the depth score for that voxel. To visualize depth scores within the VR scene, we developed a Unity package that creates a voxel-based visualization. Small cubes are placed at the center of each voxel. The color of these cubes indicates the average completion time associated with each voxel. We expose a threshold variable, which can be modified interactively, allowing designers to fine-tune the visualization to highlight relevant issues. Cubes with scores above the threshold are red, and cubes below the threshold are blue. Here, we are looking at the depth map of the head positions for the player for step 3 of the simulation. Moving the threshold, I'm not immediately noticing anything obvious in the data. I'll switch to the map for the right hand for this step. As I move the threshold slider, I can see that there are voxels with higher than average values near the wrenches. Using my knowledge of the context, I can figure out why this might be happening. The user can complete this step by removing the hose on the back of the powder feeder with their hands. These wrenches are not required for the step, so users who pick them up are taking longer to complete the task. This playtesting video confirms that this behavior is happening. Here we see a user trying to use the wrenches to take the hose off of the back of the powder feeder. This suggests that we may need to revise the instructions to clarify which tools are necessary. Or, because this step is performed using wrenches in physical reality, we may want to add wrenches in the correct size for this step. Depth is a tool to help designers identify and address potential design flaws in their systems. The interpretation of depth maps and subsequent design decisions benefit from integration with other metrics and the expertise of a skilled designer familiar with the application. Depth is a simple and highly generalizable approach. While our case study is a VR industrial training, our approach can be extended to a wide range of applications. It requires spatiotemporal data, or the position of any object over time, and the time it took for a cohort of players to complete steps, and it displays the relationship between these values.